I exercise lifting weights 10 minutes a day for 7 days. I know that when it's factored for me, it's 70. Right, it's 70 minutes because I just said it here. I'm going to put it on the side so you understand what I said. I did 7 days for 10 minutes a day. Okay, I have to multiply 7 days for 10 minutes, and that's going to give me 70. If they just write the 70 for me, saying 70 minutes, it's already been factored for me. It's already a product. You see, it's already been multiplied, and it's already a product. And then they tell me that I do 25 minutes. I do 7 days. I also do 25 minutes a day of running. And if it's already factored for me, it's going to be 175, as we just did in the previous. So if something is written in this expression, it's already been factored for me. Now what we need to do is the next step and look for what it was factored with, the greatest common factor. And when I look here and I look here, I believe the greatest common factor, or what they gave us, was 7, and that's not necessarily the greatest common factor, but we know that they were both multiplied by 7, and I know that one was 25 and the other one, one was 10 and the other one was 25. So we're trying to go from this to this, and here we have it, but with easier numbers. Here we have 12 plus 8. Let's find the greatest common factor. The greatest common factor, I believe, for 12 and 8 is 4. Yes? And you have it here. 2 times 2 is 4, 2 times 2 is 4, so the greatest common factor is 4. I don't know if you remember this from 5th grade, but what they're doing here is the prime factorization. Prime factorization. And that means this. If I have the number 12, and I want to look for the prime factorization, and I have the number 8, I can do a prime tree. I can make a prime tree. And remember, align all the smallest numbers on the left, the prime number. So I have 2 times 6, and I have 2 times 3. So my prime factorization is 2 times 2 times 3. 2 times 2 equals 4, and 4 times 3 equals 12. Yes? Let's do that with the 8. 2 times 4, and 2 times 2. Right? So now I have 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And what do I have in common? Because I'm looking for what's in common. I know I have these 2 times 2 is over here as well, 2 times 2. The 3 does not match the 2, so they're not in common. What's 2 times 2? 4. 2 times 2 is 4. So I can say that the greatest common factor for 8 and 12 is 4. So let's try it with looking for the greatest common factor for H, I, and J. Okay, let's try it. Now you can pause the video and try it on your own, or you can watch me do it. Now, some of you might be able to just see it. You can see what factor is common between 9 and 21 without doing the prime tree and the prime factorization. You might just be able to see it. But you know what? I can see it, so I'm going to go ahead and do it. I know that 3 can be multiplied into 9 and 21, right? 3. So if I do 3 times 3, I get 9. Plus, what's 3 times what to get 21? 3 times 7. And this is how you would write it. So the 3 is the greatest common factor between the two. If I were to divide this expression, the whole thing divided by 3, I would get 3 plus 7. Do you see that? Or did I jump too far ahead? I know that the GCF, the greatest common factor, is 3. Okay? That's really what I'm trying to get you to do. But I'm jumping ahead a little bit and actually using distributive property. Okay, I'm using the factor. I'm factoring it. So here we go. 14 and 28. I know that if I multiply 14 times 2, I will get 28. So why not just use 14? I'm going to use 14. And I know I have to multiply 14 times 1, yes, to get 14. And I have to multiply it times 2 to get 28. Alright, so we have 14 times 1 is 14, and then 14 times 2 is 28. So if I were to divide this expression divided by 14, I would get 1 plus 2. 1 plus 2. Here's 1 14, here's 2 14. I hope this is making sense. Alright, some of you might have to use the prime tree and then prime factorization to figure out what the greatest common factor between these two is. Now, I know that if I multiply 8 times 10, I get 80, and 56 times 7, I get 50, sorry, 50, 8 times 7 is 56. I'm sorry, guys, my mind plays tricks on me. So I know that 8 is a common factor, but this is the greatest common factor. I don't know. Let me do my prime factorization. So for 80, I have 2 times 40, 2 times 20, 2 times 10, and 2 times 5. And here's my prime factorization. 2 times 2 times 2 times 2 times 5 will give me 80. 2 times 2 is, 2 times 28 is 56, 2 times 14 is 28, and 2 times 7 is 14. So I have 2 times 2 times 2 times 7. So what do I have in common? Let's see. I have these 3 2's and these 3 2's. I don't have a 2 on this side, and I don't have a 5 on this side, I don't have a 7 on the other side. So yeah, it is 8. 2 times 2 is 4, times 2 is 8. So what do I have to multiply the 8 to get 80? 8 times 10 plus, what do I multiply the 8 to get 56? 7. And there it is. So my greatest common factor, greatest common factor is 8. Right there. And then if I were to divide this expression by 8, I get 10 plus 7. And here's what we were just practicing. So we have the products already given to us. We have 3x plus 15. What's the common factor between these two? I know it's the 3. Because 3 times x gives me 3x, and 3 times 5 gives me 15. So I can put the 3, which is the greatest common factor, outside. So I have 3 times x is 3x, plus 3 times 5 is 15. And there it is, 3x plus 15. You see that? But we would write it like this to use the distributive property. If you think you're ready to try these 3, go ahead and do it, okay? I know that do it and pause the video. I know that for the first one, my common factor is 4. So I know that I can do 4 times 4, it will give me 16, plus x. Why did I do x? Because 4 times x is 4x. Remember, I'm just going to go backwards here. Now, this is not part of the answer. But if I were to multiply 4 times 4, I get 16. And if I multiply 4 times x, I get plus 4x. So I just went backwards. Do you see that? Okay. For I have 7 and 42. Yeah, it's going to be 7. Because 7 times x is 7x. Plus 7 times 6 is 42. Okay. And for m, I have 36 and 30. I know it's 6. 6 times 6x it will give me 36x. Right? 6 times 6x will give me 36x. Plus, what number will give me 30? 6 times 5. And there we have it. Okay, here's the guided practice. Please save it for class so we can do it together as a warm-up, and it'll be part of the daily lesson. Please complete the entire independent practice. Okay, try your best and try to do it. Okay, try your best. I want to see answers in all of them, even if you are not 100% sure, so that we can check it in class together. And don't forget, there's the back of the page. Let's do it together as a little gift for those of you that watch the video all to the end. Okay, here we have what looks to be admissions. Okay, so the entrance for possibly a museum, a space museum. I'm not sure what this is, but it doesn't. It's admissions and movie pass, family night prices. Okay, so it looks like it's a movie theater, right? We have adults, which are ages 19 plus, so 12 to 50, youth, and so on. Okay, let's read what we have to do. Write 2 equivalent expressions that demonstrate the distributive property for the cost of X tickets, we don't know how many tickets, for admission and movie passes on family night. Okay, we have family night prices, okay, and we need, it doesn't say how many tickets, so we're going to use X for how many tickets. We don't know how many, but we know that there's an individual admission, okay, for one person, and there's an individual movie pass. I guess this must be some kind of museum where you see a space museum, and then you also see you can watch a movie as well, like maybe an IMAX movie. So you know that we don't know how many tickets, but I know that I can write it using the distributive property of X amount of tickets. And I know that if it's 1 ticket or 2 tickets or so on, I know that I'm going to have to at least pay $7 for one of them, right? $7. And for the movie, I have to pay $7.50. Now, I'm not writing it using money, okay? I'm writing it using decimal form. later on for my final answer I will use the money, the unit. So there we have it. I don't know how many tickets, but it's saying that I need for 7 for the admissions and for the movie. So I would write it like that. And using the other one, the equivalent, I could write it like this as well. I could write it as 7x for the movie and 7.5x. That would be the other way to write it. Is it less expensive for a youth to pay regular admission? Okay, what's regular admission? Here's admission. Regular admission for youth is $7.50. With a movie pass or go on family night? Well, $7 and just to go in, it's $7.50. But on family night, just to go in, it's $7. So right there, you save 50 cents. But we also have to add in the movie, right? So let's see. If we have on a regular night admission and a movie pass, for youth is $13.50. But what would it be if I did it on a family night? Okay, one of each. So I have 7 plus 750 is $14.50, right? Just for one person, $14.50. But the youth is $13.50. So you save $1. So it is cheaper to pay regular admission. The total cost for one person is $13.50, as we saw on a regular night. If you get the package of two, versus $14.50 on a family night. Here's family night, remember? Please copy this down right there. It is a key answer, boys and girls, because I went on and did additional work for those of you that watched the video right to the end. See you in class.